Hi, this is Ed Romaine with Conveyco Technologies, along with my colleague Dave Glodwig. We're here today to present 10 plus applications using autonomous mobile robots, AMRs, and robotics to solve labor issues. I want to start off by saying we are not from a manufacturer. Being not from a manufacturer means that you're going to see far more breadth, far more applications, far more usage of different AMRs combined in applications to help each other. It's the old saying, if you're a manufacturer, you're a hammer and everything looks like a nail. We're an integrator. Therefore, everything that we look from the perspective of our customers, what their goals, needs, desires, business requirements, and of course, their ROI. That's what it's all about. Our objectives today is that there's a huge breadth of AMR and robotics available. The trick is being able to understand which ones are best for you and how to take them and use them sometimes in a combination, sometimes separately, and that's what we'll go over. Specialized applications already exist. So if you have an application that you think, wow, nobody else does it like me, there's a better than even chance there's an AMR already existing, already being used that's going to solve that problem. As I had mentioned, combining several different models to yield higher benefits. That's something that's a great opportunity. And I hope you leave knowing more today than you knew yesterday about AMRs and what can be done and what is being done today. So let's start at some of the basics. What and why AMRs and robotics? Flexibility. We're at a point right now not seen in the material handling and supply chain world with the ability to have flexibility. AMRs provide application, material, location, process, virtually every step of the way. They are so flexible. They allow you to adjust and be agile. They save labor, and we're going to spend some time talking about that and how that works, especially in today's world where labor is always a shortage and always a critical decision to be made. It increases your labor, the efficiencies alone, by having good processes, by having the actual devices do the work for people. It improves your accuracy, your throughput. It can eliminate single point of failure. All too often, historical traditional material handling systems relied on all of it to work. Any one failure and your entire facility could grind to a halt. AMRs aren't like that. They can be designed so that and no one component brings down the system. You keep on working without losing any throughput, productivity, and your daily requirements. There's always a fast ROI when done correctly and allows for rapid growth. Once again, back to that flexibility. You can add devices, you can add different systems, you can grow while you're actually using, and it helps to handle the peaks and valleys of everybody's business very, very well. It's all a matter of design. It is so flexible that there is what we call an easy proof of concept or a POC program that actually Conveyco just launched. Um, it allows us to use that flexibility and scalability, not to mention the fact it's easy to move and locate, and a minimum infrastructure to be able to design a system. We use our right fit 7-step methodology process to walk down the path in which we start off with identifying the needs and the desires and the objectives, moving on to data analysis, going into the design system, doing emulation, being able to price out what a full system is, what a small proof of concept, a smaller segment will require, and then you'll be able to take that and make go no go decisions based upon real information. And the applications, order picking, sortation, consolidation kitting, and many, many more. At the end of the day, people ask, why are AMRs and robotics so big today? We've heard about them for a very long time. And the real answer, it's all about the money, ROI. If you take a look at this chart, in 1999, you had robots that had an average price of $80,000 plus. It's tough to get an ROI when each unit is $80,000 plus. Today, there are units that are ranging between $3,000 and $7,000. That's why you're seeing this in the news being used all over the media, because it's now a big deal. It now it justifies with a tremendous return on investment. It also really goes into the wheelhouse of what are the major issues in today's distribution centers. It's labor, space, automation. You look at this chart, which was done by Peerless, and it simply shows that the inability to attract and retain hourly workforce is growing. It's a bigger problem. Space, a big problem. Outdated storage, picking, material handling, and equipment, a significant problem, so that the AMRs come at a good time in which it provides the flexibility. It doesn't force you to buy a system that you might need in 3 or 5 years, but rather a system that you need today and maybe the next few months. And then you add on to it as you go. So it solves a lot of problems. It answers the question of how do I best provide for my business, provide for my distribution center, help turn that distribution center into an order fulfillment generator and into a profit center rather than a cost center. Question we always get asked, the difference between an AGV and an AMR. There are a number of differences, but some of the biggest ones is that an AGV is on a fixed path, whether it's tape, whether it's a navigation system, but it's fixed. It doesn't think. An AMR is autonomous. It realizes what's going on around it. It has several different technologies, SLAM, LiDAR. It looks around itself and realizes what are people, what are things, how to avoid them, when to come to a complete stop, when to reroute, change directions. So that's some of the biggest differentials between AMRs and AGVs, is the ability for it to be autonomous and to think. High-speed sortation. Now this is an example of bots that are being inducted. So you have your induction, they're taking the items, putting it on top of the bots. Right there, there's a reader up above. It reads the barcode, takes off. It's going to its chute. Each chute represents an order. They work in tandem. They're autonomous, but there's of course a central robot control system. This model, it tilts, goes down the chute to complete its order, and the order will keep on being filled as the bots keep on going until it's done, and I'll show you in a second. Right now in this type of system, we're on a mezzanine, so that we're on the top level and the chutes are down below. When the parcels come down the chute, they're being collected. When the bags are full, either a person or an AMR comes to collect them, delivers them to shipping, and right out on the truck. So it can be as manual or as automated as necessary, and that all boils down to the return on investment. What does that look like? What does it require? Because likewise, we just saw human beings doing the induction. In some cases, it's robotics. It's being able to use robotic arms to be able to place the items, the inventory, on the bots, at which point then, same exact application. They go to their chutes and they drop it. This is all a matter of labor and return on investment. What makes the most sense for you? Goods to person. This is a great application in which you have an area that has shelves, uh, low shelves, in which you then have bots that will go underneath the system, underneath the shelving, the specific shelf that it requires, lifts, picks it up, and brings it to the workstation. In this system we're looking at, there's 1,500 racks, 65 AGVs, 3,500 different SKUs. They're replenished, stored in the area. In this system, you've got a 20% savings of space, 60% savings of labor. Likewise, that same concept, but in this case, I'm using a robot. It's all about the justification. So I could be feeding from manufacturing, I could be feeding from inbound. The robot's picking the totes, putting it on the shelving. Shelving's picked up by its AMR, and now it's being delivered either to a pick window or a pick station, to storage, could be replenishment, could be shipping. But it's all about what the ROI dictates and what makes sense for your business requirements. This is a brand new technology in which it combines AMRs and high density storage to create an ASRS system. These bots travel on 3 axes. So they go up to the shelving, they climb up, go to the position that they require, take the tote out, bring it down to the floor, and then deliver it to a workstation. What makes this beautiful is that the workstations are easy to create. You can use more, you can use less based upon your actual business. In this illustration, you can see a little bit easier, but that the bots use their 3 axes, move on the floor, climb vertically, grab the tote, the inventory. You can add additional storage without missing a beat within the system. You can add bots without missing a beat so that your velocity, your capacity are totally flexible. We're back to that flexible message with AMRs. Replenishment. Here's a system that has multiple shelf levels. It will go to shelving or conveyor, whatever the inbound is, pick up a tote or a box, and then deliver it to shelving, flow rack, a work cell, another piece of automation. The opportunities are almost unlimited as to what it can do, but what it's doing is eliminating people walking, searching, and bending and stretching. Retail store. Whether this is a mixed use, whether it's a retail store, this is another system a little bit like the other where it has a shelf which it brings things on, stores, and then goes and places where it needs to. But this system is definitely designed more for human interaction where it sees the person, moves around them. It's also designed to work with people. People don't necessarily stack things and put things in a neat way. The bot actually has the ability to straighten, take it, and reposition. It knows it needs to put the box back. It looks at what the other box is and sees exactly how it needs to be stacked. Likewise, it can transfer. So the system goes around, makes all of its picks, in this case, its shoes. It then will make the multiple trips, put it back on a stack of shelving. It then indicates to the picker that, hey, I've already completed my task. He comes, takes the cart, delivers it to maybe shipping, to order fulfillment, to replenishment, whatever the next zone, the next requirement is. But it's eliminated the human from having to do that work. A zone-to-zone AMR. So robots place order totes in product aisles, pickers stay in the zones and pick the orders, and the robots transport the orders from zone to zone. This helps reduce walking, searching, keeps people focused and centered. So we have the worker, she's confirming her pick, confirms the item, places it in the order tote below. That's the blue tote you can see right over there. When it's done, she completes her scan. The AMR knows where it is and that it's complete and waiting for it, picks it up for transport, and delivers it to the next zone. The system allows human beings and bots to work in the same exact environment. Person to goods. So we've got our tote induction. We put it onto the bot. Bot travels to the pick location. You now have either people working specific locations, or in some case, they follow the bots throughout the system, depending upon the workflow. The screen tells them what the SKU number is. They then verify it with the scanner, place it in the correct order, hit task complete. When the picks are completed, they go to pack and ship. So there's many types of bots, as we had mentioned, and many different workflows that can be used to optimize them and to optimize your processes. A low and medium sortation, kitting, returns type system. We're looking at induction stations on the left and the right. We then have a high tilt sortation bot that's in the center. And then we use the pick and place bots to actually pick up the cases and take out full ones to shipping and bring in new ones to continue the order. And to give you an idea, that's what the bot looks like, at which point the induction is just simply the camera up above. And you can see the Gaylords behind him, so that those are used until full. And then when full, this bot will take it, bring it to packing, likewise bring empty Gaylords and put them back into position. The configuration, the density, this can all be changed based upon your actual application. Give you an idea, what you're looking at right now, those ladies are doing inducting. They're simply taking items, placing them barcode up, scanner reads it. You can see your Gaylords in the green on the right. The bots simply go up to the Gaylord. These have more of a cross belt top to it. The items are then discharged into the Gaylord and then go back to induction. And this process is just round robin and continued until completed. Kitting. Now, this is more of a sophisticated kitting system in which days of old, in days of old being maybe 2-3 years ago, you would have a person pushing a cart and building a kit. In this case, what you would wind up doing is using this AMR, which picks up the cart and travels with you, but it also provides a number of technologies with the cart that allow the operator, and nothing better than a boy and his robot. Here we go into to start the picking. The AMR is going to direct him to exactly where he needs to stop. It has a full pick to light system. You can see the red light on the barcode's license plate. Tells him which piece to pick, the quantity to pick. Likewise, the card has a pick to light indicator. We'll see that in a second, but here's the label. You can see the red dot by his thumb, telling him exactly where to put the label. He hits the task complete. The laser navigation on the bot will then, when complete, go to the central storage. It's the end of the process. It either then goes to manufacturing, it could go to shipping, wherever its next destination is, and the process is repeated, keeping people in their zones and making sure that what they pick is 100% accurate and marked. Delivery to work zones. This is a manufacturing cell, but it could just as easily be distribution. You see a AMR with top and bottom positions in which it comes up to the workstation. Inventory is unloaded, and likewise, inventory that's ready to be moved is loaded, and it repeats, and it takes it throughout the facility. Eliminates people with carts, eliminates humans from having to go from place to place and possibly putting it in the wrong location. Feeding a buffer storage. Now this looks like a VLM, but it is actually not a VLM. Instead of being trays, those are individual totes, individual cells that are all used autonomously. You have an AMR now that's bringing up either inventory or orders, brings it to the conveyor for induction. It's read. The system will then take them, store them, buffer them, likewise bring it out when it has to be brought out to either shipping or manufacturing, wherever it needs to go. And the system is constantly repeated. It can also be delivered to the front pick window rather than the AMR, if preferred, to do your picking there. So it all depends upon the actual process and the speed, the throughput, and the application. Receiving. What you don't see is a person. We have the forklifts, AMRs, they're able to go in. In this case, it's RFID. It could just as easily be barcode scanning, number of other technologies, so that we've now inducted. We have acknowledgement that we're here in the facility. We place it to be stored, whether it's into a high bay, ASRS, and that's just depending upon your flow. Using ASRS, Automated Storage and Retrieval System, with AMRs, the pallet comes out, the bot reads and verifies it's in the right position, lifts its load, understands where all the other bots are and the location it needs to go to, and then begins its journey. It's constantly scanning, knowing, looking. It sees another bot that is either waiting or in a position that it didn't expect. It reroutes itself and goes again. Delivers it to its location, and then waits for its next direction, what else to pick up and deliver. Depalletizing, full case handling. So here we have our bot again. He goes to his load, picks it up. He's routing his shortest path to where he needs to go. Brings it to a robotic arm, depal. The AMR then continues on to find the next load that he has to bring over. The arm then unloads. We now have a label being printed on it. So we've taken inventory that was bulk, put it onto the conveyor. It's now a label is printed. It's now an order. It's now going someplace. It now is a piece of inventory that's being shipped to a specific company or person who's ordered it. Gets routed down to sortation because now it's going to have to be delivered. In this case, we have another robotic arm that puts it in a U-boat cart. This could be a pallet, but in this case, what we're actually looking at is a system for inner city 1-2 hour delivery. Takes the U-boat, the cart, and is right now buffering it. When all the items are there, it's going to bring it into the van or the truck, so that way the van can leave and fill its orders. Now, this is how you get 1 hour, 2 hour, needless to say, same day delivery, and especially in urban areas. Because when you take a look, this is a low ceiling, inner city type structure, which has always been a problem. and different from how we build most of our distribution centers. But this is how AMRs can help solve that problem. I always like to hit these conversations because people are always like, what's it cost? What's it cost? And that is on a case by case basis, of course. But to at least keep your mind thinking about the basics, you have certain criteria. You've got your floor space, you've got your throughput, and of course your dollar. The, the more throughput, the least amount of floor space, that's your upper right quadrant, the more expensive. The least throughput, the least floor space, your lower left. The idea is finding the blend of what makes sense for your business case and what creates the return on investment for you. And that's what AMRs are so flexible in being able to do. I call this living the dream. I've had this piece of simulated art for about 5 years. 5 years ago, it was like, wow, yeah, maybe someday. I mean, we got everything going on here, our arms. But what it really shows is that in just the 5 years that I've had this piece of art, it's gone from, wow, wouldn't that be nice, to this is pretty much reality. Now, I don't know how many drones are actually moving inventory within buildings, but we do have drones that are doing inventory management and taking inventory off of high bay. So that is already here. That is a today application. So my only point is that things are moving very quickly, very fast, and the name of the game is to see what makes sense for your business requirements, and to see whether or not the flexibility makes sense. Thank you very much. I appreciate your time. If you have any questions, please feel free to reach out to either myself, Ed Romaine, or my colleague, David Lodwig. Thanks again.